Good morning, AI enthusiasts. Today on Daily AI Brief, we're diving into some groundbreaking developments across the tech world, from OpenAI's latest tool for workplace productivity to a paradigm shift in biomolecular research with NVIDIA and the fascinating emergence of agentic AI in the financial sector. There's a lot to unpack. Stay tuned to see how these innovations might just change the way we work, live, and create. OpenAI has just lifted the veil on ChatGPT Work, a powerhouse application integrating ChatGPT, Codex, and the advanced GPT 5.6 models. This tool aims to revolutionize office productivity by enveloping several AI functions into one cohesive suite. It showcases the prowess of the GPT 5.6 family led by the Sol model, tailored for efficient multi-step task execution across platforms, from desktop to mobile. This rollout is a strategic move to address business hurdles in AI adoption, ensuring smoother workflows and advancing accessibility. Delving into the technicalities, ChatGPT Work functions as a unified AI agent designed to manage intricate workflow tasks. It features the Sol model at its core, alongside Terra and Luna, providing diverse performance capabilities. Sol can execute complex tasks with fewer computational resources, reducing costs significantly as compared to previous iterations, making it a viable option for businesses mindful of their budgets. Codex integration, allowing seamless operations from scheduling to document generation. This integration enables ChatGPT Work to function as both an operational assistant and a creative engine, crafting code and crafting prose with equal finesse. A robust architecture supporting multi-step reasoning and decision-making, effectively simulating human-like problem-solving processes. This capability is enhanced by the introduction of max reasoning effort and an ultra mode, which employs sub-agents to handle diversified, simultaneous tasks, thus increasing efficiency. Accessibility through APIs that connect different models and tools, optimizing for various user interfaces. The APIs are engineered to be adaptable, handling various inputs and executing them across different digital environments. Benchmark metrics show that Sol leads in state-of-the-art results across coding and knowledge tasks, all while operating with lower costs due to efficient token use. Initial user access is limited to specific plans like Pro and Enterprise, ensuring early adopters can utilize the model's full capabilities while OpenAI navigates broader availability. Yet, the launch comes with trade-offs. The initial rollout is restricted to trusted partners, driven by governmental requests, which sparks concerns about equitable accessibility. This restricted access potentially delays widespread adoption and may impact OpenAI's ability to iterate on feedback from a diverse user base. Moreover, the changing regulatory landscape poses potential obstacles to wider adoption. As enterprises grapple with incorporating new AI technologies into existing systems amid evolving compliance requirements, OpenAI anticipates that its integration flexibility will ease these transitions, but widespread rollout will depend on how these regulatory realities unfold. For those eager to dive into ChatGPT Work, consider exploring their official page at openai.com/chatgptwork. You could also peruse the GPT 5.0 overview. openai.com/index/gp56/UTM source OpenAI for in-depth spec details, or sign up for the API to integrate these capabilities directly into your projects. Takeaway: ChatGPT Work may just set a new standard in how enterprises leverage AI for productivity gains. By providing cost-effective, high-performance solutions and adjusting to regulatory and infrastructural constraints, OpenAI positions itself as not only a leader in AI advancement, but also as a bridge between innovation and practicality. Meta is making waves with the launch of Muse Spark 1.1, a cost-effective multimodal AI model tailored for enterprise applications. As businesses grow wary of escalating AI expenditures, this model offers high performance at a reduced cost, stepping into the market with a strong message of affordability without sacrificing quality. Its ability to enhance coding, tool use, and multimodal understanding positions it as a formidable competitor against major players like OpenAI and Anthropic. Technically, Muse Spark 1.1 excels through multimodal reasoning framework. This robust feature supports complex, multi-step tasks, allowing for minimal human intervention. The model's ability to process inputs across text, images, and video enables comprehensive insights, crucial for diverse enterprise needs. Tool and computer use capabilities. Enhanced capabilities streamline operations, making Muse Spark 1.1 pivotal for enterprises. Tasks such as automated coding and tool management are executed with greater efficiency, promising improvements in workflow continuity and decision-making. Integration via MetaModel API. The model's availability through the public preview of the MetaModel API ensures developers can seamlessly integrate its features into existing applications. This integration is expected to be straightforward, enabling quick adoption. Performance reviews boast that Muse Spark 1.1 can outperform Google's Gemini on coding and reasoning benchmarks, though independent evaluations are still pending. In numbers, the enterprise AI spending is projected to soar to $135 billion this year, emphasizing the importance of cost-saving innovations like Muse Spark 1.1. Nevertheless, there are inherent trade-offs. The lack of independent validation of Muse Spark's capabilities could hinder immediate confidence from potential users. Additionally, competition remains fierce. Established models, such as those from Anthropic and OpenAI, present significant barriers to market entry, while the real-world integration complexities for enterprises could delay broad adoption. Practical steps for implementation. Developers can access the model via the MetaModel API and refer to the official Meta blog, aimeta.cog, introducing Muse Spark MetaModel API for implementation examples and thorough documentation. Hands-on experience. Exploring the available tools within the Meta AI app offers practical exposure to Muse Spark's capabilities, ensuring smoother transitions into enterprise environments. Takeaway. Muse Spark 1.1 could revolutionize AI accessibility for budget-conscious enterprises, provided its capabilities withstand broader, independent scrutiny. By enabling more efficient, AI-driven solutions, it may lay the groundwork for future developments, potentially ushering in a new era of affordable enterprise AI. Google Research is at the forefront of wearable technology with the launch of SensorFM, a groundbreaking foundation model for health monitoring. By pre-training on a staggering 1 trillion minutes of sensor data from 5 million individuals, SensorFM sets new standards in predicting health indicators, aiming to bridge gaps between raw sensor data and critical health insights. Technical significance. This model is technically significant due to several key innovations. Mixed modal sensor data training. SensorFM uses advanced machine learning techniques to integrate diverse data modalities from wearables, ensuring more accurate and holistic health predictions. It leverages a mixed data approach, synthesizing information from motion sensors, heart rate monitors, and other health metrics to offer comprehensive insights. Real-time monitoring capabilities. Users benefit from immediate feedback thanks to the model's ability to process data in real time. This aspect is crucial for applications like activity tracking, where instant recommendations can enhance user adherence and outcomes. Classroom method for task design. A unique classroom methodology where the system learns by tackling increasingly complex tasks enables SensorFM to continuously adapt and improve its predictive performance. This setup mimics natural learning processes, enhancing the model's efficiency and versatility. Aggregated data inputs. SensorFM capitalizes on aggregated 1-minute feature windows to ensure that the inputs are both detailed and manageable. While this approach balances processing efficiency with depth, it sometimes risks missing finer scale variations occurring within those intervals. Performance and limitations. SensorFM outshines traditional approaches in 34 classification tasks, demonstrating enhanced accuracy across various domains like activity recognition and exercise monitoring. Despite these advances, there are several important limitations to consider. Limited data sources. The model primarily derives its data from Fitbit and Pixel Watch users, which could result in biases, as these devices do not universally represent all demographics. Thus, the generalizability of SensorFM's insights across different populations remains an open question. Although SensorFM exhibits superior technical performance, it still requires rigorous validation against established clinical standards to verify its utility and reliability in medical contexts. For a deeper exploration of SensorFM's methodologies, consider diving into the research paper, research.google/pubs, Scaling Wearable Foundation Models /UTM Source OpenAI, or keeping up with updates via the Google research blogs. Future implications. The broader implications of SensorFM's technology extend to numerous fields. Personalized health monitoring. With the capacity to adapt health insights to real-time data, wearables could evolve from simple tracking devices to integral components of personalized health management. Healthcare decisions. More accurate patient data can significantly aid healthcare professionals in making informed decisions, potentially transforming patient outcomes and care efficiency. Research and development. Future research can explore deeper connections between sensor signals and health indicators, expanding the capability of wearables to predict health issues proactively. Takeaway. SensorFM is poised to transform wearable devices from mere data collectors into critical tools for health decision-making, heralding a new era in health monitoring with far-reaching potential impacts on both technology and healthcare industries. IBM has shattered previous records by unveiling the first sub-1 nanometer chip, featuring a revolutionary 0.7 nanometer transistor architecture. This leap integrates a phenomenal 100 billion transistors into a fingernail-sized chip, promising up to 50% better performance and a 70% boost in energy efficiency as compared to its predecessors. Technically, IBM's innovation is attributed to the nanostack design, which uses vertical stacking of transistors. This architecture maximizes transistor density, enhancing performance capabilities significantly. By altering the traditional two-dimensional layout of chips, the nanostack design allows transistors to be layered three-dimensionally, akin to constructing a skyscraper where each floor represents a layer of transistors. This design effectively increases the computational capacity while maintaining the compact footprint desired in modern processors. Advanced thermal management solutions are incorporated to cope with the increased heat from densely packed components. This involves novel cooling methods, such as incorporating microfluidic channels that circulate cooling fluids within the chip layers, ensuring that the heat does not affect the chip's performance. The precise alignment and bonding required for sub-1 nanometer fabrication demand new manufacturing processes. Techniques such as extreme ultraviolet lithography (EUV) are employed to etch these microcomponents with the precision required for such small scales. This ensures that each layer is perfectly aligned, which is crucial for performance and reliability. But challenges remain. The sophisticated manufacturing requirements could delay mass adoption, with precise wafer alignment and fiscal constraints posing potential barriers. These manufacturing processes are not only technologically demanding, but also financially burdensome, with costs potentially doubling those of previous nodes. Moreover, thermal management continues to be a concern for realizing optimal performance. Despite advances, maintaining efficiency while managing heat in a densely packed configuration like the nanostack is challenging, requiring ongoing research and development for solutions that can be scaled practically. For a deeper understanding, explore Muse, htnewsroom.ibm.com/2026-0625. IBM debuts world's first sub-1 nanometer chip technology. Use source OpenAI for official announcements and insights into the new nanostack architecture. IBM's breakthrough not only advances chip technology, but also sets a new benchmark in the semiconductor industry, forcing competitors to accelerate their innovation paths. Takeaway: IBM's sub-1 nanometer chip may recalibrate the standards for AI and computational processing against a backdrop of energy efficiency. This new class of chip technology is expected to catalyze advancements across numerous sectors, including automotive, consumer electronics, and healthcare, potentially transforming how these industries harness AI applications. The implications for energy consumption are profound, with data centers possibly reducing operational costs significantly, guiding future innovation not only in chip design, but also in sustainable technology development across the semiconductor landscape. CrowdStrike has turned the spotlight on new prompt injection threats targeting AI systems, revealing a dark side of AI exploitation that risks data integrity and business process manipulation. These malicious techniques embed harmful prompts in seemingly innocuous content, creating challenges in detection and posing severe risks to enterprises reliant on AI. Technically speaking, these attacks involve malicious instructions cleverly hidden within various digital assets. For example, simple email signatures, usually benign, can be weaponized by embedding code snippets that AI systems may inadvertently execute. Document metadata, often overlooked as a storage of non-essential information, becomes a vector for these Trojan-like entries. Similarly, image files, traditionally secure, may harbor embedded text serving as triggers for AI when accessed, illustrating the ingenious means attackers employ to evade conventional security measures. CrowdStrike tracks over 150 techniques, developing a comprehensive taxonomy to help organizations understand and combat these threats effectively. This extensive list provides a detailed roadmap for risk managers and IT security professionals, crucial given the 89% year-over-year increase in AI-enabled adversary operations. To address this, CrowdStrike's Falcon AI detection and response tool is designed to offer real-time monitoring, capable of analyzing AI prompts, responses, and agent actions to intercept potential threats before they exploit system vulnerabilities. As of 2025, more than 90 organizations have reportedly been impacted by these tactics, emphasizing the growing threat landscape. Prompt injection attacks are ranked prominently on the OWASP Top 10 list for large language model applications, signifying their potential to undermine AI functionalities if left uncontrolled. To protect your enterprise, deploying CrowdStrike's Falcon AI detection tools is a crucial first step. Businesses are urged to closely monitor the constantly evolving landscape of AI threats, amplifying the importance of cybersecurity frameworks tailored specifically to AI environments. Additionally, comprehensive employee education is vital. Training staff to recognize signs of indirect prompt injection attacks can significantly bolster an organization's defensive posture. The takeaway here is clear. AI security transcends traditional network protections like firewalls. Proactive measures, such as anticipating and mitigating against sophisticated prompt injection threats, are imperative for sustaining robust, secure AI operations. This proactive stance not only safeguards organizational data, but ensures continuity and trust in AI-driven business processes, a critical component as AI integration in enterprises continues to deepen. In a groundbreaking move, Particle 6 has thrust an AI-generated actress into the spotlight, with Tilly Norwood set to headline the feature film Misaligned, set in the fantastical Tillyverse. This unique production aims to unravel complex themes of identity and digital existence through the perspective of an AI, infusing existential inquiries with humor. From a technical standpoint, the creation of Tilly Norwood involves several sophisticated elements. 1. Generative models. Tilly is designed using advanced generative models capable of crafting lifelike digital characters. These models utilize deep learning to mimic human expressions and reactions, although the specifics of the model architecture and training process remain undisclosed. 2. Hybrid craft. The integration of AI outputs with traditional filmmaking techniques requires meticulous planning. This involves not just creating the digital character, but ensuring seamless interaction with live-action elements. Expert filmmakers and AI developers collaborate to produce a narrative that feels cohesive and immersive. Ethical considerations. The opaque nature of the training data used for Tilly Norwood raises pertinent ethical and privacy concerns. There is ongoing debate about the provenance of data, especially whether it involves unauthorized use of human performances, leading to potential legal challenges. Despite the excitement, budgetary details remain elusive, reflecting the experimental nature of this project. This lack of transparency can affect investor confidence and influence the film's marketing strategy. Moreover, the success of Misaligned hinges on audience reception, which is unpredictable given the novelty of an AI taking the lead role. There are strategic steps that interested individuals can take to engage with this evolving narrative. Stay updated. Follow Particle 6 for announcements regarding release dates and behind-the-scenes insights. Participate in discussions. Engage in forums discussing AI ethics and entertainment, which can provide a richer understanding of broader implications. Explore AI documentation. If possible, review any documentation released by Particle 6 to comprehend the technical underpinnings of their AI model. The introduction of AI characters like Tilly Norwood could redefine the intersection of technology and cinema, offering new storytelling possibilities. Yet, it also escalates ethical debates concerning the replacement of human actors and transparency in AI training methods. This film not only challenges traditional filmmaking, but also ignites a discussion about the future landscape of creative industries. Ultimately, Misaligned represents a significant step in exploring AI's role in mainstream media, potentially carving out a niche for AI-centric films that question the human experience from a digital viewpoint. On June 23, 2026, NVIDIA launched the BioNeMo Agent Toolkit, marking a significant milestone in the realm of biomolecular research and drug discovery. With an impressive integration of NVIDIA's technological expertise accumulated over a decade, this toolkit is set to advance the capabilities of researchers, allowing them to take on complex scientific problems with AI-driven solutions. The BioNeMo Toolkit comes with several innovative features. 1. High-performance integration. At the core of the BioNeMo Toolkit is the NVIDIA BioNeMo framework, which seamlessly combines the NIM microservices, facilitating advanced interactions between AI agents. This framework is designed to improve efficiency in model training and handling complex computational tasks such as protein structure prediction, molecular docking, and biomarker discovery. 2. Fold CP framework. This component is particularly noteworthy for its ability to manage large molecular assemblies exceeding 30,000 residues. By distributing intensive computations across 64 NVIDIA B300 GPUs, the Fold CP framework ensures that scale and speed are no longer bottlenecks in biomolecular modeling. Collaborative and automated science. The toolkit supports process automation for running computational experiments, enhancing genomic analysis, and enabling generative chemistry tasks. Such capabilities are crucial in accelerating the pace of drug discovery and other biopharmaceutical research. From a performance standpoint, the BioNeMo toolkit promises up to a twofold improvement over its predecessor models. While specific numerical benchmarks are yet to be fully disclosed, preliminary collaborations, like those with the University of Washington, suggest substantial efficiency gains. For researchers eager to dive into NVIDIA's offerings, exploring the official documentation, https://nvidia.com/news press release details/2026, NVIDIA announces BioNeMo Agent Toolkit, tools for agents to accelerate scientific discovery, /default.aspm source OpenAI, provides an excellent starting point. This resource includes detailed guidance, workflow plans, and demo scripts hosted on NVIDIA's GitHub repositories, designed to facilitate the seamless integration into existing research infrastructures. However, the toolkit does pose challenges. High computational demands could prove prohibitive for smaller labs, and there's a need for detailed performance metrics to ascertain its effectiveness across various applications. In conclusion, NVIDIA's BioNeMo toolkit might transform biomolecular research, setting new standards for collaboration and innovation in the life sciences. As it embraces open-source initiatives, the toolkit not only accelerates scientific discovery, but potentially democratizes access to cutting-edge research capabilities. During the GTC 2026 event, NVIDIA unveiled an ambitious strategy for AI model co-design, targeting significant enhancements in efficiency across various sectors. This initiative marries silicon, software, and AI architecture into a cohesive development approach, drastically reducing GPU design timelines and offering new insights for enterprise deployments. Key technical features include 1. Holistic cross-layer design philosophy. This strategy integrates hardware and software layers, creating a seamless interaction between them. The introduction of silicon photonics plays a critical role, utilizing light instead of electrical signals for data transfer within chips, thereby boosting speed and reducing power consumption. AI-driven process in GPU architecture. Traditional GPU design typically takes about 10 months and requires a team of 8 engineers. NVIDIA's AI-driven process can complete this complex task overnight, showcasing how AI can accelerate design cycles without compromising on accuracy. 3. Reference designs for AI factories. NVIDIA provides systematic guides for transforming conventional data centers into AI factories. These templates focus on optimizing cooling systems, energy usage, and orchestration, facilitating seamless integration of AI across infrastructure. Nevertheless, some trade-offs and challenges persist. The gap towards fully autonomous AI in chip design is recognized, acknowledging that human oversight remains essential. Scalability of these strategies in real-world scenarios is yet to be fully validated. Practical steps and exploration. Visit GTC 2026 sessions. For comprehensive understanding, explore sessions available on NVIDIA's GTC 2026 page. dubnvidia.com/enas on-demand session GTC 26 S82154 Force OpenAI. Explore reference designs. Delve into NVIDIA's blog on ARASP detailed frameworks, AI Factories blogs at plum/blog/AI-factories, reference design, use source OpenAI. Review open model documentation. NVIDIA's documentation on open models can guide practical application. NVIDIA documentation. Docs.nvidia.com's NCP inference are latest NVIDIA's open models across modalities.tml, UTM source, OpenAI. Implications and future potential. The shift towards collaborative design promises enhanced efficiency and reduced operational costs. Broader adoption could spur AI applications across diverse sectors, potentially setting new industry standards. Continued AI advancements based on this framework may eventually pave the way for more autonomous capabilities, altering the future landscape of engineering and design. In conclusion, NVIDIA's strategies signify more than mere evolution. They represent a potential revolution in AI development efficiency, with the promise of substantial cost and time savings across industries. In a groundbreaking shift, Agentic AI is automating KYC and AML processes in the banking sector, offering promise in efficiency and adherence. With players like IBM spearheading this movement, banks are exploring new horizons of operational security and digital convenience. The core of this transformation is IBM's Model Context Protocol, MCP server. This technology facilitates real-time queries, significantly enhancing fraud detection capabilities through safer payments APIs. By utilizing real-time data streams, financial institutions can detect anomalies and fraudulent activities promptly. This real-time capability is essential, with operational benchmarks reporting a reduction in manual workflows by as much as 30%, leading to increased accuracy in compliance measures exceeding 85%. Agentic AI facilitates autonomous decision-making by integrating modular agents capable of processing dynamic inputs instantaneously. These agents can make decisions without human intervention, streamlining operations and fortifying compliance workflows. This level of automation not only addresses the immediate needs of KYC and AML processes, but also prepares financial institutions for future regulatory demands through a compliance-by-design framework. Despite these advancements, the technology faces scalability challenges. The adaptability of AI systems across different banking environments, each with unique legacy systems, remains uncertain. Furthermore, evolving regulatory standards demand continuous updates and calibrations of AI models to maintain compliance. Practical steps for banks include studying IBM's developer/ibm.com//insights Agentic AI is rewriting KYC AML banking, source opening, to integrate these cutting-edge technologies effectively. Case studies like that of Farmers State Bank illustrate tangible benefits, showcasing enhanced operational efficiency and customer service improvements since their implementation in 2025. Agentic AI signifies a tectonic shift in the financial landscape, ushering in improved accuracy and speed alongside operational cost reductions, potentially as high as 25%. However, with this transformation come challenges, primarily related to job displacement concerns and the ethical implications of algorithmic decision-making. To harness the full potential of agentic AI systems, banks must navigate trade-offs between automation and human oversight, ensuring balance in sensitive compliance roles. Maintaining customer trust and setting new industry standards depend on how well these systems uphold compliance integrity. In conclusion, while agentic AI is positioned to redefine compliance processes in banking, institutions must remain vigilant, continuously updating and optimizing these systems to address regulatory changes and operational demands. The future promises a blend of AI-driven efficiency with traditional oversight, propelling banks into a new era of compliance. NVIDIA has introduced a sophisticated suite of tools within its NeMo framework aimed at facilitating synthetic data generation particularly tailored for the financial sector. This approach, utilizing the NeMo curator, allows developers to create diverse datasets that can help overcome data limitations often encountered in financial AI research. By employing large language models, the system can generate data that enhances model training, thus enabling a wider range of analytical insights and validation of financial AI models. The significance of synthetic data in this context cannot be understated. It directly addresses gaps in data availability and quality, which are crucial for building robust AI applications in finance. The recent release of the Nemotron 4 340B models, optimized for such data generation, emphasizes NVIDIA's commitment to improving AI performance across industries. Financial institutions are anticipated to leverage these tools to enhance their models, resulting in better performance and accuracy in various financial applications. With NeMo Curator, users are able to design sophisticated synthetic data generation pipelines, transforming the way datasets are built and diversified. The integration with OpenAI-compatible APIs ensures that users can seamlessly adopt these technologies into existing systems, reducing friction in implementation. On a deeper level, the technical specifications of the NeMo framework include support for NVIDIA's built-in inference server. This capability streamlines the implementation of generated data into working financial models, further enhancing workflow efficiency. The connection to NVIDIA NIM endpoints also facilitates smoother integration into financial applications, enabling institutions to create datasets tailor-made for specific scenarios. As NVIDIA's technologies show improvements in AI model performance and accuracy, they aim to generate diverse datasets at scale, though exact performance metrics are still under development. Its tools present solutions to common challenges, such as data scarcity and regulatory compliance issues, ensuring robust data practices in finance. For practical application, visiting NeMo's official page, https://wnvidia.com/enus/ada-science/products/NeMo, and exploring the NeMo Curator documentation/docs.nvidia.com/NeMos-curator/curate-text-synthetic can offer comprehensive insights. NVIDIA also provides examples through its AI model distillation guidance, helping institutions to replicate successful use cases. However, it's important to note some trade-offs. The effectiveness of synthetic data in replicating real-world scenarios is still under scrutiny, with ongoing research addressing these challenges. Data quality and realism present hurdles, and integrating these advanced tools may encounter resistance due to existing workflow dependencies. Additionally, regulatory uncertainties surrounding AI-generated data use remain complex concerns. Finally, the adoption of synthetic data is positioned to reshape the landscape of financial AI, democratizing access to quality datasets and potentially leading to enhanced decision-making processes. If financial institutions successfully implement these tools, they could achieve both cost savings and competitive advantages in their analytical capabilities, although continued empirical validation in real-world settings will be crucial for long-term success. That's a wrap for today's Daily AI Brief. We've journeyed through workplace innovations with OpenAI, health advancements from Google, and the fascinating entrance of AI actors in film. As we look to the future, these stories remind us of AI's power to transform industries and daily life. Join us next time as we continue exploring this rapidly evolving tech landscape. Thanks for tuning in.